So after receiving the profiles and alignments from InfraWorks, I was able to collaborate and coordinate with the alignment designers who told me where the station locations are most likely to happen. And then I developed the custom subassembly. And in that custom subassembly, you can see that it's very simple. It's basically just a graphical representation. However, it does have a couple of targets. So the spacing, as you can see, the spacing between the tracks is kind of constantly varying. And that's what it does. Also, I had an option to have a station there. So there's an additional subassembly that I can show you that has a station, that has a platform and a station. So when I change the region, I can change the subassembly to the one that includes a station. So this was all beginning to create some more detailed 3D models for what the concepts that we are evaluating. And this is what we end up with. So that's the corridor model. Now, of course, these are just frequencies on a corridor that give me a different shape of my subassembly, and you can recognize the station and the platform there. So you have this tool to extract solids, and that was the next drawing that I was going to open. So you can recognize the station, the platform. All of these piers are now beginning to look like piers, and of course the guideway. So the task was to decide where these piers will be and locate them with more detail. And sometimes, like in this area here, we couldn't have any piers. So then they said, just leave it without piers. That will indicate that we need a more substantial structure there, a different system to span, to go over that long span. So what helped me in a great deal is from the geolocation. If you assign a coordinate system to your drawing, you'll be able simply to go to this online map and get an aerial map. And I used that because I didn't have to think, where's the insertion point? What's the format? Does it have a world file? Do I have raster design installed? This is done. And it's in your AutoCAD map and Civil 3D. So that was one big thing that we did. The other big thing was to do with roadways. All of this sparked a lot of roadway redesign. The entire area needed to be redesigned. And we had what we call a knot. The knot is where all the roads are converging. So with our new links to the airport, we couldn't get through there, so we had to go through a tunnel. And the big question was, this is even before we got to deal with any utilities. The question is, where do we go under? Where do we have a trench, or what I call a U section? And where can we afford to have a fully submerged, if you like, tunnel? And what is the minimum? What's the minimum cover that we can go with? So there came to the rescue another custom subassembly. So you're looking at the profile and you're looking at the tunnel or at that corridor. And then if I go and take a quick look at it with Object Viewer, you will notice that it's all U section, of course, because we are too shallow. So now if I want to, I said I have to go deeper with this. So I go and change my profile to go deeper, and notice that there's a segment of that tunnel where that feature line is missing. That's the segment of the fully submerged tunnel. So, but I think you get the idea. So with custom subassemblies, a lot of decisions that we had to make, a lot of representation of what we're doing, and having that to reflect in 3D model was done automated like this.